In this video, we're going to talk a little bit about multidimensional arrays. Hopefully this is a little bit of review from CS1, but it's going to be important in class in the coming days. So remember that arrays are containers. So basically arrays just are a collection of variables that are of the same type. So maybe we're going to store a set of doubles that represent the high temperatures in a given week, or a set of strings that store the names of the students in the class, which is something you worked on in lab this week, or a set of integers that store, say, the number of cars that are in a row in a parking lot, right? Arrays are easily accessed, and they provide an order over those numbers, and we index them starting at 0. So here's an example, say, of the high temperatures in the coming 6 or 7 days, right? So today is day 0, and next week, a week from now, is day 6, right? Next, whatever it is, 6 days from now, right? And we can see there's a trend in the high temperature, and they're ordered, right? The actual index provides us some information, and there we have stored one nugget of information that tells us something. But remember that arrays themselves are a type, right? This is a data structure that just happens to store some other data structures. So the question is, what if the type held in the array was itself another array, right? So here instead, I don't know why it didn't display that to begin with, instead of storing only the high temperature for the next 7 days, what if we want to store the high and low temperature, right? So we can again see today is at value 0, and then the high temperature is stored at index 0, and the low temperature is stored at index 1, right? So to get today's high temperature, you would say next temps today, right, which is index 0, and then I ran out of room, but we want the high temperature, which is at index 1, right? So if we wanted, the last day of next week, or the second to last day of next week, the low temperature would be next temps 5 1, right? And there's some things we can do with this, right? We know before that we could say next temps dot length, right? And that gives us the length of this array here. In this case, next length is 7, right? But we can also get, if we want to get the length of this guy, we need to index this array. So that's why if we say next temps, say 0, right? So that gives me this array itself, and we can say that dot length, and that equals 2, right? So here, this accesses the original array itself. This accesses one of the index arrays. And what that sort of leads to, if you think of two-dimensional arrays in this manner, is that not every one of these arrays needs to be the same size. So that gives us this idea of full versus jagged arrays. So in the last example, we saw that it was a full array because every array, every subarray was the same length, right? Every row had the same length. Here, if we're looking at, say, a list of phone calls that came in for a day, we don't get the same number of phone calls every day, right? We might get more some days and less others. So in this case, this is a jagged array. So we can still get the length of, say, this subarray, right? Phone calls 0 dot length is 4, right? But phone calls 1 dot length is not equal to 4, it's equal to 2, right? And similarly, if we try and index phone calls, right? If we want this number, it's 0, 3, right? But phone calls 1, 3 is index out of bounds, right? Because row 1 does not have 4 elements. It doesn't have a 4th element for us to index. So those are all things to keep in mind when we're working with two-dimensional arrays. It's an easy way to store sets of information. Again, all of these need to be the same type, right? Here, all of these are strings. But we know the first index can mean one thing and the second index means another, right? So that's 2D arrays, and we'll be working with those a little bit more in class and in the next couple homeworks.